Now, moving on to the next and last report for today. It's
Paula Redweik, professor from the University of Lisbon. She will speak about the energy and geological studies based on photogrammetry and LiDAR data.
Can you hear me? Okay. Good afternoon, ladies and gentlemen. My name is Paula Redweik, and let me welcome you all in my country. I'm coming from the University of Lisbon, more precisely from the Faculty of Sciences. In the next few minutes, and I'll be brief, I present you shortly the faculty where I'm working and some of the projects we are involved with, so that you'll get a panoramic picture of our activities in the field of photogrammetry in Lisbon. The Faculty of Sciences occupies nowadays 8 different buildings in the campus of the University of Lisbon in Campo Grande. It was founded in 1911, so we just celebrated last year its first century. The faculty has 10 departments and a broad offer in courses of fundamental sciences and engineering. The academic staff includes about 400 elements that educate a population of 5,000 students. The whole university has about 20,000 students. These are distributed as shown in bachelor, master, and PhD studies. About 600 students are following the courses in the Department of Geographic Engineering, Geophysics, and Energy, where I belong to, which are listed here, including a bachelor and master in geographic engineering and a master in geographic information systems. Geographic engineering in Portugal includes all geospatial sciences: surveying, geodesy, cartography, hydrography, GIS, remote sensing, and of course, photogrammetry. In the master courses, analytical photogrammetry is taught, accompanied by a strong practical component, including all the steps of map production, terrain modeling, and orthophoto generation. And we are now introducing 3D urban modeling at medium scale in the program. In the bachelor courses, the emphasis is laid on close-range photogrammetry with architectural purposes. These are some student projects, or for general 3D object modeling. Our research activities have a quite interdisciplinary character by contributing with their results to research projects in other fields such as geology, archaeology, and energy. For instance, the monitoring of sea cliff erosion is being done at the Algarve and at the west coast near Lisbon in order to better model the cliff behavior as a function of several factors for risk mapping. It's being done by photogrammetry, resorting to the oldest aerial surveys in the country, dating from the 40s and 50s of the past century. All other existing surveys done till the present are being used as observation epochs. The changes in the cliff between flights correspond mainly to rock falls on the cliff top and debris deposition on the cliff base. They are detected by comparison of stereoplotted lines and DTM differences. All occurrences are located, measured, classified, and registered in a GIS database where several space-dependent factors are also mapped, such as geology, pluviometry, land occupation, human pressure, etc., in order to pursue spatial analysis and draw conclusions about cliff stability, leading to risk management decisions concerning the coast. In the West Coast, high-priority cliffs are locally surveyed in several epochs. 3D models are built by photogrammetry and by using terrestrial laser scanning. The virtual models are used by geologists for visual interpretation and mapping of geological features on the vertical wall. We are still investigating which method is more adequate for each site and what kind and dimension of changes can be detected between epochs. The recovery of old aerial photography, hibernating in its analog format in the archives of several institutions, has meanwhile become a passion. Scanning glass plate collections from 1938 and celluloid films from the 40s has occupied much of our time in the last few years and taken most of our patience. Although we find some material in really bad conditions, most of the images can be rescued and become so a second chance as eyewitnesses of the past. Tests showed astonishing good geometric properties of old-size cameras in spite of the lack of calibration information typical for these flights. Fairchild cameras didn't work so well in our tests. Old aerial photography allowed not only widening the time window of the cliff and coast evolution study, but also recovering missing landscapes due to dam construction and the associated flooding. Especially in the north of the country, archaeologists were able to localize in large orthomosaics of aerial photos dating from before the flooding several sites of interest nowadays underwater, such as important Roman roads and bridges. The quest for renewable energy in the sunniest capital in Europe, Lisbon, required also our collaboration to study the photovoltaic potential of urban landscapes. Algorithms have been developed to derive all the needed geometric information from LiDAR data and deliver the amount of solar radiation reaching a spot to a specific day and time or along the year. To achieve this result, effective shadow and sky view factor algorithms, important for the calculation of diffuse radiation, were also new developed. Since urban landscapes include not only roofs but also facades, our approach is also able to calculate the solar radiation for each square meter on the facade of a building, and query for the best areas on roofs or facades for installation of sun collectors. As far as we know, this is an item not yet solved in any commercial or open source software. Well, thank you. Большое спасибо. Obrigada.
Вопросы?
Will there be questions for the speaker? No questions.
Небольшое
A small